Assalamu alaikum wa rahmatullahi wa barakatuhu. May the peace, mercy, and blessings of Almighty Allah be with you. I welcome all of you to another video. And from today, we are going to start the organic chemistry from the very first chapter, that is Basics of Organic Chemistry with IUPAC Nomenclature. So, today we'll be dealing with the basic part, means the basics and the common name wala part. Okay, so before starting, let me show you something. These are the notes that I have talked about in the strategy video that I will share with you, my Kota notes. These are indeed the best possible notes for organic chemistry that can help you get a complete full score in organic chemistry if you combine these with NCRT. So these are the notes. I will not talk about these notes, but I have summarized it over here. Okay, I will be dealing with the topics, the concept, and few examples. But for more examples, for practicing more, you will get ample amount of examples in the notes. Okay, I have just taken selected questions. I'll just say you how to solve the question, the concept, and how to apply the concept in the question. That will be teaching you for every topic. So let's get started. So the first topic we'll be dealing with is hybridization. It's a topic that you can understand better when you study chemical bonding in inorganic chemistry. But right now we're doing organic chemistry. I can just give you the method of how can you find out the hybridization, but not the field right now. So let us talk about how you can find out the hybridization. So 2 points are there. One is sigma bond and lone pair. So first we'll deal with what is sigma bond, and then I will explain what is lone pair. So sigma bond, right now, again you don't know what is sigma pi bond. So just remember, whenever there is a single bond, there is sigma bond. Whenever there is a double bond, one is sigma, another one is pi. Whenever there is a triple bond, you will find one sigma and two pi. Means whatever will be the case, there will be one sigma only. Whether it's single bond, one sigma. Double bond, one sigma, another pi. Triple bond, one sigma, the rest two will be pi. So I hope the concept is clear for sigma bond. Let's see few examples. So let us talk about carbon. So carbon is having 4 valency. So the first point is very important, that carbon is having 4 valency, because many a times you will not be given the hydrogen. Okay, in the exam you might be given, but many time in the class or whenever you talk with any organic chemistry discussion, then you will not be mentioning that itna hydrogen hai, utna hydrogen hai. No, you have to understand it. Like if it is written like this, so to understand that this carbon is having 3 valency, so 1 valence is remaining, that will be hydrogen. If it is nothing mentioned, if nothing is mentioned, you have to understand that there is hydrogen. Similarly, this carbon is having 3 bond, so 1 bond is remaining, 1 valence is remaining, that will be hydrogen. All right. So that is the first point, that you should remember that carbon is having 3 valency. Okay, we are talking about sigma bond. Okay, so let us say this is the example. This carbon again having 1 bond over here, that means 3 bonds are remaining, that means 3 hydrogen will be there. Now this does not mean a triple bond. It is not a triple bond. It is three single bond. It is not a triple bond, but it is 3 single bond. But this one is a triple bond. This is a triple bond. Okay, between two atoms, two elements, 2 atoms, there will be a triple bond. But this is not between 2 atoms. It is between this and this, then this and this, and this and this. So definitely that is not a triple bond. That is 3 single bond. I hope you will you have the knowledge of this. Okay, it's a very basic thing. So here there are 3 single bonds, so there will be 3 sigma over here, 3 sigma, and it is also single bond, a sigma. So here this carbon is having 4 sigma over here. Okay, I hope it's clear. Talking about this carbon, again, yeah, it has the 1 sigma bond over here, so this sigma is for both. Okay, for both. It is not that this sigma is for that only. No, if it is a sharing, so it will be for both of them. It is for both of them. So this sigma is also for this and also for this. Now this carbon is having 3 bond over here, triple bond, 3 bond. It's 3 bond is there, but that's a triple bond. That means 1 sigma and 2 pi. So 1 sigma over here and another sigma over this side. So this carbon have 2 sigma. I hope it is clear. The concept of sigma bond, I hope it is clear. We'll further you will get it more clear when we discuss the examples of hybridization. Let us now talk about lone pairs. Let us take an example of oxygen. So oxygen have atomic number 8. If we write the configuration, 1 is 2, 2 is 2, and 2p4. If you don't know how to write this configuration, we'll be dealing with it in the chapter of atomic structure in physical chemistry, or in the periodic table of of inorganic chemistry. We'll deal with that. Right now, just remember nitrogen and oxygen. The scenario of nitrogen and oxygen will be enough for right now. So oxygen is having, this is the outermost shell, valence electron is the electron in the outermost shell. So outermost shell is n is equal to 2, so it is having 6 electrons. So oxygen have the 6 electron in the outermost shell. By generally, normally oxygen forms 2 bonds. It can be a 2 single bond, it can be a double bond, whatever, but the remaining is 4 electrons. There is 2 lone pair. Pair means 2 electrons, so 4 electrons, that means 2 lone pairs. Okay. Similarly, for the case of nitrogen, it is having 5 valence electrons, and it generally forms 3 bonds. It can be a triple bond, it can be 3 single bond, it can be a double bond and a single bond. So any combination, but it generally forms 3 bonds. So remaining one is 1 lone pair. I hope that is also clear, the concept of lone pair. So these two are the important one as far as organic chemistry is concerned. Remember this right now, and we'll deal it with in details in inorganic chemistry. What is sigma bond, what is lone pair, and specifically what is hybridization, we'll deal with in inorganic chemistry in great details. Okay, so now let's come to the example. Let us come to the example. So first example is LA. This is a question from Neet only. So as I mentioned that you must make a common name copy. So while reading these notes, whenever you will get any common name, the first common name you get over here, phenol. Okay, from here, over here only you get the phenol. Phenol. Now phenol is also called as carbolic acid. One is carbonic acid. Carbonic acid. Carbonic acid. Okay. Another is carbolic acid. Phenol is known as carbolic acid, and carbonic acid is different. Okay, carbonic acid and phenol is the carbolic acid. So first you have to write the first common name over here, that phenol is this, and it is also carbolic acid. Similarly, you will get many one. Here you have the alene question. Write the structure of the alene. You will get many, toluene and aniline. All these are very important things. So just write it, add it to your common name copy. As I mentioned in the strategy video, make the common name sheet. That is very important. So write it. So right here you have the alene. The first one is alene. So let us see the example of alene. It is C double bond C double bond C. If it is written like this, you have to understand that carbon is having 2 valency, so 2 remaining is 2 hydrogen. Here also 2 hydrogen. That should be in your mind, that you should be able to identify it or write how many hydrogen is there. That is a very basic thing as far as organic chemistry is concerned. So now how we have to find out the hybridization. So let us see the first carbon. Okay, so what is this carbon? It is having the bond actually like this, 1 double bond and 2 hydrogen over here. Okay, it is 1 double bond. Okay, 1 double bond and 2 single bond. So single bond means a sigma and sigma and pi. Okay, so how many sigma are there? It is 3 sigma. It is 3 sigma. Talking about lone pair, as I mentioned, for carbon it is having 4 electrons, valence electrons, and it is having 4 valency. Okay, it can have maximum 4 bonds, and here you have the 4 bond, 1 2 3 4. So 4 bond is there, means no lone pair is remaining. Okay, and by general you will not get lone pair as far as carbon is concerned. You will generally not get a lone pair for on carbon. You can get on oxygen, nitrogen, but not on carbon. You can get minus charge on carbon. We will deal with the next example only, but by default there will be no lone pair on carbon. Okay, if it forms 4 bonds. So simply you can check. Don't remember that carbon can't have lone pair. It can definitely have lone pair. Just check it. Okay, that 4 bond is there, that means no lone pair. The methodology that I mentioned, that carbon is having 4, 1 2 3 4. If it makes 1 bond, that means a 2 bond, that means 1 lone pair is remaining. So like that. Okay, but that is not the situation for carbon. For carbon generally you don't have lone pair. So here 3 sigma Now hybridization, if it is the sigma plus lone pair, so sigma plus lone pair, if it comes to be 2, hybridization is sp. If it is 3, it is sp2. If it is 4, it is sp3. Right now just remember this. Just remember this. What is sp, what is sp2, what is sp3? We'll deal with in organic chemistry chemical bonding, but right now just remember that if sigma plus lone pair comes out to be 2, it is sp hybridization. If it is 3, sp2. If it is 4, it is sp3. Just remember it right now. So what is this? 3 sigma means 3, 0 lone pair, so total is 3, means it will be sp2. This carbon, similarly this carbon, same, both are same thing. Here also you have the 1 sigma and here 2 sigma, 2 sigma and 0 lone pair, so this will also be 3, that means sp2. Okay, and if we talk about this carbon, it is having 1 sigma this side and another sigma this side, means 2 sigma, that is 2, 0 lone pair. Again 4 bond is already there, so no lone pair, and it is 2, that means sp. Okay, just check it over here. It is sp2, sp2, sp, sp2. All right, sp2, sp, sp2. Okay, let me write the answer also over here. So this one is sp2, sp2 and sp. I hope the first example is clear. The next example is C triple bond C minus. What is minus right now? So in organic chemistry, a minus means a lone pair. A minus means a lone pair. Now you will say that I have told you that carbon is having 4 valency. 4 valence and electron. How it is 5? It is 5 na. 1, 2, 3 and here you having 2. 5. Yeah, that is definitely 5. That is why it is mentioned minus and not simply lone pair. Okay, because this 1 electron is the stolen electron, is not the electron of carbon. It is a stolen electron. This is not the electron of this carbon, but it is a stolen electron from someone. Let me explain you in detail, but this will be discussing in GOC only, the bond cleavage. So if it is the case, let's suppose any one atom is there attached to this carbon. Any bond is formed by 2 electrons. You must know this, that any bond means 2 electrons. So one of this atom, one for this atom. So already this belongs to this carbon, but sometimes this carbon, it takes the electron, it steals the electron from this as well. So finally it forms, see, 1 electron of its own and the other one is a stolen electron. This is the stolen electron, and it forms a lone pair. So we don't write it lone pair because that is not a lone pair of carbon, but a stolen electron. We write it minus. Okay, we write it like this, minus. So minus means a lone pair where 1 electron belongs to this carbon, another one is a stolen electron. I hope it is somehow clear right now, or if it is not clear, just remember that minus means a lone pair. Minus means a lone pair. We'll deal with it again in the GOC chapter when we're talking about the bond cleavage. All right, so let us talk about the hybridization of this right now. Okay, so this means minus means a lone pair, as I mentioned. So just right now let us replace it with a lone pair. So carbon and triple bond C minus, that means a lone pair. So how many sigma? Let us deal with the hybridization of this carbon, because rest of what you can do. Okay, this is having 1 bond over here, means remaining 3 hydrogen. So total you have the 3 sigma over here and 1 sigma here, no lone pair, so 4, that means sp3. And here you having 1 sigma, another sigma, 2 sigma, sp. Dealing with this, it is having 1 sigma over here and 1 lone pair. So 1 sigma and 1 lone pair. Alright, it is having 1 sigma, these two are pi bond. So 1 sigma and having 1 lone pair, so it is 2, it is also sp. So this is sp, this is sp, and this is sp3. Okay, let us check it once. here it is. Yes, sp, absolutely, it is sp over here. All right, moving forward, this is sp. Next concept is delocalized lone pair. Now what is delocalized lone pair? Delocalized lone pair means resonance. Okay, the lone pair or the negative charge which is involved in resonance. अब ये resonance क्या होता है भाई? So resonance is nothing but a topic that will be dealing with that we will be dealing with in general organic chemistry. Right now, just remember any lone pair. Just remember this, okay? At this point, right now, just remember this. No, that is not to be remembered, but right now, just remember it, because right now you don't know what is a resonance. So any lone pair that goes in resonance, that means it is known as a delocalized lone pair that does not participate in hybridization. A very important point. You miss it and you lose the marks. Okay, a very important point. So let us discuss about the example mentioned. It is nitrogen, carbon, and a nitrogen. Okay. Now, where is the lone pair first of all? As I have mentioned, nitrogen, oxygen, देखते ही समझ में आ जाना चाहिए. Okay. Whenever you see nitrogen, oxygen, your stimulus your brain must be activated, and you must get the stimulus that there should be a lone pair. There should be a lone pair. Here nitrogen is having 3 bond. One is this bond and 2 there hydrogen bond, 3 bond. That means 1 lone pair. I have explained it in the detail. You can watch the video once more if you do not understand. Okay. And here also it is having 3 bond, and here also it is having 3 bond, 2 over here and 1 hydrogen. Okay, but nothing we have to do with all these things. We have to deal with this because this is the one lone pair. Now first of all, don't consider resonance, just write the hybridization of this nitrogen. Just tell me the hybridization of this nitrogen. So what we will say, here you have the 1 sigma, here 2 hydrogen is there. Okay, 2 hydrogen is there. That means here you have the 2 sigma, here you have the 2 sigma and 1 lone pair. So 3 sigma, 1 lone pair. That means it is 4 sp3. But my dear friend, that is wrong. It is wrong. Why? So what is the answer? sp3. So sp3 is wrong over here because this lone pair actually goes to resonance. How it goes to resonance? Right now, just remember that this one goes to a resonance. Okay, if you get a question you can't solve right now, so do not worry. Just remember this point: the delocalized lone pair or negative charge that goes in the resonance will not participate in hybridization. And whenever we'll study GOC resonance, after that you can solve this question. You can understand that which will go in the resonance and which will not. So right now, just remember the delocalized lone pair or negative charge does not participate in hybridization. So this nitrogen has a lone pair which will go in the resonance. So this lone pair will not be considered as in the hybridization. So what do we do? So how many sigma? 3 sigma and 0 lone pair, because the lone pair is resonance. This will be sp2. So 3 sigma, that will be sp2 hybridization. Okay, so the answer is sp2 and not sp3. I hope that's clear. If you talk about this nitrogen, it is having again 3 sigma and 1 lone pair. So all these are sp3. This is also sp3. Okay, if you talk about the carbon, so carbon is having 1 sigma and another sigma. So 3 sigma, that means sp2. Okay, I hope that's clear. Next topic, let us move to the next topic. It is degree. Now degree of carbon and nitrogen and degree of hydrogen, oxygen and halogen. X means halogen. Okay, so carbon and nitrogen का खुद का डिग्री होता है, हाइड्रोजन, ऑक्सीजन और हेलोजन का बगल वाले कार्बन होता है, उसका डिग्री होता है. कार्बन और नाइट्रोजन, पहले तो डिग्री क्या होता है? सो फर्स्ट ऑफ ऑल, व्हाट इज डिग्री? डिग्री मीन्स कितने कार्बन से जुड़ा हुआ है, टू हाउ मेनी कार्बन इट इज अटैच्ड. इफ द एटम इज कनेक्टेड टू one carbon it is 1 degree. If it is connected to 2 carbon are 2 degree. If it is connected to 3 carbon it is 3 degree. And if it is connected to 4 carbon it is 4 degree. Example is given over here that this carbon attached to 1 carbon, here it is attached to 2 carbons, it's 1 degree, it is 2 degree. Attached to 3 carbon, so it is a 3 degree. Here attached to 4 carbon, that is 4 degree. Okay, so carbon nitrogen का खुद का डिग्री होता है, यानी directly this carbon or nitrogen is attached to how many carbon, the degree will be that. like this is the example. Okay, this example is for carbon only. Here I mentioned carbon in these examples, so you can see the carbon is attached directly to 1, so 1 degree, 2 to 2 degree, 3 to 3 degree, 4 to 4 degree. Similar situation for nitrogen as well. Like if we talk about this nitrogen attached to how many carbon? 1 carbon and 2 carbon, so it is a 2 degree, it is a 2 degree nitrogen. Okay, now for hydrogen, oxygen and halogen, it does not have its own degree. That means it does not matter to how many carbon it is attached, but it matters that how many carbon that carbon is attached to which this atom is attached. Means the carbon, like let us say this is halogen and this is the situation. Okay, this is the situation. So this halogen is connected to 1 carbon, so its degree is 1 degree. That is not the case because it does not have its own degree. It does not matter to how many carbon this is attached, but what matters is this carbon, the carbon to which this is attached. Yes, the degree of this carbon will be the degree of this carbon. So this carbon is attached to 1 and 2, so it is 2 degree, so this will be 2 degree and not 1 degree. Okay, so for in the case of hydrogen, oxygen and halogen, first look after that, first check to which carbon is this attached, and then check the degree of this carbon, and that will be the degree of this, whether it's halogen or hydrogen or oxygen, whatever the situation. Okay, so let us see the example. Look at this example. Now if it is attached to 1 carbon, we said 1 degree. If it is 0 carbon, that also means 1 degree. Okay, 0 carbon means it is not attached to any carbon, it is also 1 degree, like methane. So it is not 0 degree because nothing is 0 degree, it is 1 degree. Okay, remember that. So right now let's come to this. It is asking that how many 1 degree carbon is there over here. So let's check it out. First of all, this carbon is attached to how many? 1, so it is 1 degree. This carbon is attached to 1, 2, 2 degree. This carbon is attached to 1 and 2, 1 and 2, it is 2 degree. Again this one is attached to 1, 2 and 3, so it is 3 degree. With this carbon, it is attached to 1, 2, 2 degree. So like that you can solve. Okay, let us talk about this carbon. This carbon is attached to 1 because carbon has its own valency. The atom to which carbon is to how many carbon is carbon attached, that is the degree of carbon. So this carbon attached to 1 and 2, 2 degree. This is attached to 1, so it is 1 degree. Okay, this carbon is again 1 degree because it is not attached to any carbon. 0 carbon, that means also 1 degree. I mentioned that 0 carbon means 1 degree as well. So this carbon attached to no carbon, that means again that means 1 degree. Alright, and this carbon having 1, 2 carbon, so it is 2 degree. So how many 1 degree are there over here? How many 1 degree? 1 degree carbon. So 1, 2, 3, and let us check anyone is remaining. This carbon is attached to one carbon only. Okay, this one is remaining over here. I missed this carbon. It is mentioned to 1 carbon over here, and here it is nitrogen. So nitrogen, nothing to do with nitrogen. How many carbon it is? It is 1 carbon, that is 1 degree. Okay, so right now we have the 4 over here, so it is 4 1 degree carbons. I hope that's clear. Degree, कार्बन नाइट्रोजन का खुद का डिग्री होता है, जबकि हैलोजन, ऑक्सीजन एंड हाइड्रोजन का बगल वाले कार्बन का डिग्री होता है. ठीक है, I hope that's clear. Okay, this one is clear na? This carbon is attached to 1 carbon over this side, and it is a nitrogen over here, so nothing to do with nitrogen. It is 1 carbon over here, so it is a 1 degree. Okay, so I missed it in the first time. So here we have the 4 1 degree carbons. I hope that's clear. Moving forward in the classification, now let us classify organic compounds. So if we classify organic compounds, we have 2 parts. One is simple chain and another one is ring. So one is open, acyclic, or remember this is acyclic, and here you have the alicyclic. Okay, both are different things. So open acyclic, that means a simple linear chain, and ring cyclic closed, that means a closed chain. Now in this situation, if it is a single bond, it is carbon carbon single. It must be carbon carbon single bond and not between anything else. It must be carbon carbon single. Carbon is important. It must be carbon carbon single bond and known as paraffin. Single bond carbon carbon single bond is known as paraffin, that will be saturated. Whenever it's a double bond or triple bond between carbon, that is unsaturated. Double bond is called olefinic, triple bond is called acetylenic. That is the one that you have to memorize, this paraffinic, olefinic and acetylenic. Just remember this. Okay, not so important, but just remember this. Talking about ring cyclic closed. Okay, this one you add it in the common name. Okay, the paraffin means carbon carbon single bond, olefinic means double bond, and acid. It might come somewhere, so just remember, nothing is harm to remember or something extra. So homocyclic and heterocyclic. Homo means hetero means different. Means in the ring, if you all are carbon, nothing is mentioned means it is carbon. Okay, here means it means 1 carbon, 2, 3, 4, 5, 6, 7. All these are carbon over here. Similarly, over here you have 6 carbons. All are carbon. That means it's a homocyclic. But if it is like this, nitrogen or another nitrogen, pyrimidine, previous one pyrimidine. So in this situation, it is heterocyclic. It is heterocyclic because something else is there apart from carbon, that is hetero. Hetero means different. So different atoms are there in the cycle. That is heterocyclic. Now again, each of them is classified in aromatic and alicyclic. Aromatic, what is aromatic? How it is aromatic? We will deal with in GOC. Aromaticity, Huckel's rule, 4n plus 2 rule. We will deal with it in the GOC chapter. But here, just leave it right now. Just remember that we have aromatic. And what is alicyclic? Alicyclic means if the ring has minimum 1 sp3, means at least 1, means greater than equal to 1 sp3 atoms, greater than is equal to 1 sp3 atoms, then that will be alicyclic. Then that ring will be known as alicyclic. Ample amount of examples are there in the notes. You can check over here. All these examples are there. You can check. You can practice from here. Okay. Next point, we have a point over here that these alicyclic compounds have similar property to this aliphatic. Okay, remember this. A point to remember, just nothing to do with that. Remember this. But alicyclic is having similar properties like the aliphatic or the open compounds. Okay, the next topic we have is homologous series. Important topic. Important. Homologous series means two compounds are there. Okay, having the same functional group. Functional group or function. Functional group क्या होता है? OH, NH2. All these things are functional group only. Okay. So functional group. I will give you the functional group priority order and the trick to remember this as well in the next upcoming video before starting IUPAC nomenclature. So here the functional group must be same, and functional group is the one that decides the chemical properties. So if the functional group is same, then the chemical property will be same, and this two has a difference of CH2. That means molecular mass 14, carbon का 12 and hydrogen का 1, दो hydrogen यानी 2. So total 40 molecular mass. Alright, what is that? 16 लिख दिया. Sorry, it's not 16, it's 14. कार्बन का 12 and इसका 2, so 14 है. Sorry, it's not 16, it's 14. Okay, so CH2 यानी 14 का जो है molecular weight में अंतर आना चाहिए for being an homologous series, a member of a homologous series. Now molecular weight is definitely what? Physical property. So there is a difference in molecular weight. There will be again क्या लिखते हैं? Sorry, it's different physical property. It should be different physical property. Okay, different physical property, same functional group, the same chemical property. If it molecular weight is different because 14 का अंतर आ रहा है, there is a difference of 14, so there will be different physical property. All right, you can say over here as well. It is written over here. Same functional group differed by CH2, having the same functional group, so same chemical property, and having different molecular mass, so different physical property. Also having the same general formula. We'll discuss about general formula right now. What is general formula? But before that, let us see an example over here. This is CH triple bond CH, and its formula you can see C2H2. Add CH2 and you will get what? C2 plus C, that is C3, and H2 plus H2 H4. That comes to this. Okay, so HCC, and you add CH2 to this, so form CH3. Okay, there is difference. So no difference in functional group, no functional group is there indeed if we say according to IUPAC, but triple bond is also a functional group. But whenever we talk about IUPAC, multiple bonds are not considered functional group. So yes, we can say that these two are same, or we can say the triple bond over here is functional group because both are triple bond, same functional group we can say. But if we talk about with respect to IUPAC does not consider triple bond as a functional group. We consider it as a double bond, multiple bond. Double bond, triple bond considers multiple bond only and not functional group as per IUPAC. Next, we have 1 degree, 2 degree, 3 degree amines are different. Amines means NH2. R NH2, it is amine. R C double bond O NH2 is amide. So amine, and this is amide. So degree of amine means degree of the nitrogen. As you can see over here, it is attached to 1 carbon to 1 degree. If we talk about this one, RNHR, that means it is 2 degree. If we talk about RNRR, what is R? R means carbon, a carbon chain, a carbon chain. So here a carbon chain means 1 carbon will be attached to there, and whatever might be over here, but here there will be 1 carbon. Okay, so these are very basic things. Okay, what is R? So here you have 3R means 3 degree, means 3 carbon will be there, 3 degree. So 1 degree, 2 degree and 3 degree all are amines, but they are different functional group. Different what? Different functional group. Different functional group. All are different functional group. Similarly, for amide, there are different functional group. This is amide. If you have over here, if you have over here, so all these are 1 degree, 2 degree, 3 degree respectively. Here you have the amide, 1 degree attached to 1 carbon. Here you have attached to 2 carbon, 2 degree attached to 3 carbon, 3 degree. Okay, they are different functional group, different functional group. Similarly for alcohol and phenol as well. Alcohol is ROH and phenol is this. What is another name of phenol? I mentioned in the starting only. It's carbolic acid. Okay, carbolic acid. So these two are also different functional group. So if you remember that these two are different. If these two are there, that can't be a homologous series. And similarly, this will be important when we are talking about the functional group isomerism. Okay, so I hope this homologous series is also clear. Now coming to an important point, that is general formula. By default, the general formula is CnH2n plus 2, and we'll modify it as per requirement. CnH2n plus 2 is the by default. Now whenever in the question, in the compound, there will be 1 pi, yeah, for 1 ring. For each pi, for each ring, you will deduct minus 2 hydrogen. So if it is CnH2n plus 2, deduct the 2 hydrogen and it will be CnH2n plus 2 minus 2. That means it is this. Remove this 2 hydrogen if it is 1 pi or 1 ring present. If one halogen is present, remove 1 hydrogen, and if 1 nitrogen is present, add 1 hydrogen. Let us see the example. Ester. Right now, just remember that this ester will discuss in the functional group priority order, all the functional group. That is ester. So CnH2n plus 2 is the by default, and 2 oxygen are also there. So let us write 2 oxygen. Okay, whatever is there, 2 oxygen, 2 as you can see here I mentioned. So write 2 oxygen are there, 2 oxygen. Now 1 pi bond, you can see double bond. This is a double bond. So 1 sigma, 1 pi. So 1 pi means minus 2 hydrogen. This is hydrogen. So minus 2 means the answer will be CnH2nO2. Okay. Again for acid, if you say acid, this one, so again CnH2n plus 2 and 2 oxygen are there, O2. And again 1 pi bond, so minus 2. So CnH2nO2. Now can you see that these two are same? Absolutely. Now let us enter the common name. So the few important points in common name is N, iso and neo. So understand it very well. That is a very confusing topic, iso and neo. So N, everyone knows what is N. N means a straight or linear chain. Like this, it is having 1, 2, 3, 4 carbons. So butane, it's a linear chain. So N, a straight linear chain means N butane. This can also be represented like that. A line diagram. It simply means here 1 is carbon, 2 carbon, 3 carbon, 4 carbon, and that's also linear. Linear means no branch. Okay, it does not mean that zigzag. It is also linear because no branch is there. It's linear. Now when to use iso, there will be one methyl group. CH3 is methyl. One methyl group at the second last carbon. Look at this example. It is CH3, CH2, CH2, CH3, CH3. How many? 5 carbon. The last carbon, This can also be written over here because and both the side it can be same. Anyone you can say the last carbon or the second last carbon. That doesn't matter in this case. But if it's radical, we'll discuss about radical. So in that case that matters. But here this is the last carbon, the second last carbon, one CH3 in the second last carbon, that is iso. So it will be known as isopentane. Let us see the example of isobutyl. Now butyl, it's not butane, it's butyl. Yl means like methane. So methane, that is a compound. But if we remove one hydrogen, it will form CH3. That is known as methyl. That is radical. So yl means radical, butyl. So butyl means an iso is there, means at the second last you must add one CH3. So one carbon, two carbon, and three carbon. Okay, butyl means four carbon. So three carbon over here, and that is the radical. And iso is there, so second last. Now this is not the last because that is the radical, so that is the first carbon, second carbon, third carbon, that is the last carbon, and this is the second last carbon. So add a C over here. C means CH3 only. I mentioned that do not write CMH3 while practice. Okay, in the exam, board exam, you must write. In the competition, in the competitive exam, do not write because that will be a simple waste of time. So what will be the final answer for this isobutyl? So butyl means four carbons, so three carbon over here, the second last carbon, another carbon. That is isobutyl. What is secondary? Secondary means 2 degree. Tertiary means 3 degree. We'll deal with that. Let me first complete neo and then we'll solve these two questions as well. So neo means same thing, but there will be 2 CH3 at the second last carbon. Like this question, this is the 3 means again 5 carbon, but this is the linear chain of 3. IUPAC name होता तो यहाँ पर pentane लिखते, but in common name we'll simply write it neopentane. We'll simply write it as a neopentane. The question might come that what is IUPAC name of neopentane? So for that you must definitely know what is the neopentane. How can you write IUPAC name without knowing neopentane? So for that common name is important, especially N-iso-neo. So CH3, C, CH3, and here you have the CH3, CH3 in the second last carbon, the last carbon, the second last carbon having 2 CH3, that means it is neopentane. So 5 carbon is the first compound that can have neo. इससे पहले अगर 4 कार्बन की नियो बनाना चाहे तो वो नहीं बन सकता, not possible. So first 5 carbon is the first compound that can form neo. Now some names are written over here, vinyl, allyl. So just remember these names, okay? Vinyl means carbon, double bond carbon, and this halogen. So it is vinyl halide, and if it is this, they are known as allyl halide, okay? Similarly, ethylene chloride and ethylene chloride. Ethylene dichloride. So both are having eth means 2 carbon. Now don't go, this is not IUPAC name, okay? Don't go by IUPAC, that's not IUPAC, that's a common name. Now first let us talk about geminal and vicinal. Geminal dihalide, vicinal dihalide. How to remember that which one is geminal, vicinal? तो geminal means gem, कहते हैं ना he is a gem, means वो एक जीनियस है, परफेक्ट है, यानी वो एक ही कार्बन में 2 क्लोरीन को समा सकता है, यानी 1 कार्बन कैन होल्ड 2 क्लोरीन. इट इज अ जेम, इट इज अ पावरफुल वन, इट कैन होल्ड 2 क्लोरीन टुगेदर. तो इफ इट इज अ जेम मीन्स 1 कार्बन पे ही 2 क्लोरीन लग सकता है. तो विसाइनल में क्या हो जाएगा, तो अलग अलग कार्बन पे क्लोरीन लग जाएगा. Okay, so let me talk here over here, explain it in better way. So in one situation there will be both the chlorine in one carbon and another situation in the different carbon. So if it is a gem, this carbon is a gem, means it can take 2 chlorine together, but this is not a gem, it's a vicinal, means it cannot hold 2 chlorine together, so another one will go to the next carbon. I hope right now it is clear how to, that's not a concept, there is a trick to remember geminal and vicinal that I used to remember. So geminal means that 1 carbon both will be there, and vicinal means 2 separate carbon that will be there. Now let us talk about how to remember ethylene chloride and ethylene chloride. So for this, first of all, remember that this ene does not mean double bond, okay? Ene means double bond in IUPAC, but here ene is written, it is ene in the name, but nothing to deal with double bond. In the entire structure there is no double bond, although ene means double bond, but in the structure there is no double bond. So just remember this, it can create confusion in the exam. Now Whenever there is two chlorine together, in this situation there is two chlorine together, consider it as one unit. Both the chlorine together, and consider that both are fused and one unit. But whenever there is two different chlorine and two different site, means consider it is two chlorine. Okay, now that will be done. Here you have chloride means one, here you have dichloride means two. So one means both are fused to one, means geminal condition, and in di means two chlorine, so it is the separate condition. So just remember that whenever there is in the same carbon both chlorine, that consider this to be one unit. Whenever there is two, that is again a trick, that is nothing to do with concept. Okay, that is nothing to do with concept, these are tricks to remember. All right, I hope this is clear, and these are very important. These four names are very important. You have to remember this, my brothers, you have to, and sisters. You have to remember this: vinyl, allyl, ethylene, chloride, ethylene. This will be you'll come to this when you read the haloalkane chapter, but right now remember this from right now only. Now coming to secondary and tertiary butyl. What is secondary? I mentioned 2 degree. Now butyl means 4 carbons, 1 2 3 4. What is this? This is n-butyl. It's n-butane. Okay, I made the compound only to n-butane. If it was this n-butyl, that is not a matter. N-butyl is this. Now when not to make n-butyl, to make secondary butyl, means to the radical. What is secondary butyl means? Means the radical, the first carbon to which the radical is attached, it must have 2 degree. It must be 2 degree. So if it is 2 degree, that means it must be attached to 2 carbon. So just take 1 carbon and put it over here. Is it 2 degree? Absolutely. It is having 1 carbon, 2 carbon, that is 2 degree. Is that clear? So carbon, 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 and another carbon. If it was like this, what was that? Isobutyl. But if it is over here, that is a secondary. Because this carbon to which the radical is attached, it must be 2 degree. So 1 and 2 degree over here. Similarly, tertiary butyl is 3 degree. So just take the another 1 carbon and write it over here. Take the other carbon and write it over here. Okay, 1 2 3, and you will get the answer. Like that you can write secondary butyl, tertiary butyl, anything. I hope that is clear. 2 degree and 3 degree, secondary butyl, tertiary butyl. Just remember these names: n, iso, neo, and secondary, tertiary. These will that will be enough for your common name. And the last part, for forming the name in the common name, you must know the naming. For 1 carbon it is formed, for 2 carbon acid, for 3 propione, 4 butyl, and 5 it is valar and amylo, and 2 specific name are there, that is acrylo and croton. What is this star? Means this carbon is a carbon of functional group. For example, C double bond C COOH. It will be acrylo, and this is ic acid. Alright, ic acid. Carboxylic acid is known as ic acid. Ic acid. So in the common name it is known as ic acid. So this will be the situation, it will be acrylo. So this is the carbon star marked, that means this is the carbon of a functional group. That is the carbon of the functional group. Similarly for croton, this is the case of croton. So croton means this is a carboxylic acid, so crotonic acid. As you can see this situation, this will be known as crotonic acid. Because this is croton, the functional group, and this is ic acid. So crotonic acid. If we talk about this situation, 1 carbon means form. And what is this? Carboxylic acid, so formic acid. Okay, I hope that is clear. That is for today. Okay, we have dealt with hybridization. Let us revise quickly. Hybridization means sigma bond plus lone pair, single bond 1 sigma, double bond 1 sigma, another one is pi, triple bond 1 sigma 2 pi. For carbon 4 valency. For nitrogen it is having 5 valence electron, normally makes 3 bond, so it is having 2 lone pair. For oxygen it is 6 lone pair, 6 valence electron. If it forms 2 bonds, it will having 2 lone pairs. Remember these examples. Whenever the lone pair goes in resonance, that is delocalized lone pair or a negative charge, that is not included in the hybridization. Negative charge means a lone pair, consider it as a lone pair. Degree of carbon and nitrogen is the degree of its own, means to directly to how many carbon it is attached. But for case of HOX, it is the degree of the adjacent carbon. Okay, for classification and this example I took some time because I missed over here that 1 degree carbon. this carbon I missed, that it is also 1 degree. So it was better to deal with each and every carbon over here and check everyone. So this was the carbon, we attached to one carbon over here, another nitrogen, nothing to do with nitrogen with in case of degree. So one carbon means it is also 1 degree. So total 4 carbon was there here for 1 degree. Next we deal with the classification. Organic compound is divided into two parts, open और दूसरा है ring. Open में it is a single bond, carbon carbon single bond, saturated, carbon carbon double bond, carbon carbon triple bond, it is unsaturated, carbon carbon single bond paraffin, carbon carbon double bond olefinic, and carbon carbon triple bond is acetylenic. If we talk about the ring, we have the two part homocyclic, all the members of the atoms of the ring are same, and heterocyclic, different atoms are present in the ring. Each of them are divided into aromatic and alicyclic. Aromatic will deal with the GOC. Alicyclic means minimum one sp3 carbon is greater than is equal to one sp3 atom must be there. So at least one or more sp3 atom will be there, and the property of this alicyclic is similar to aliphatic compounds. Homologous series, they have the same functional group, so same chemical property. They have a difference of CH2, that is molecular weight 14, that will be having a different physical property because molecular weight is a different for that, for both of them. 1 degree, 2 degree, 3 degree amines are different functional group. 1 degree, 2 degree, 3 degree amides are different functional groups, and alcohol and phenol are different functional groups. General formula, it is CnH2n plus 2 by default. If there is one pi, remove 2 hydrogen. If there is one ring, remove 2 hydrogen. So that doesn't mean for 1 pi only. There will be 2 pi, remove 4 hydrogen. 2 ring, 4 hydrogen. Okay, 2 pi, 4 hydrogen. 3 pi, 6 hydrogen. So that is for 1 pi. For 1 the situation is mathematics is given. If there is 2 pi, 3 pi, n number of pi, multiply it with n. Alright, if it is 1 halogen, remove 1 hydrogen, and if it is 1 nitrogen, add 1 hydrogen. It is add, okay. इसको नहीं भूल जाना, ये माइनस है, ये प्लस है. These two are minus, and here you have to add 1 hydrogen. Next is the common name. N means a linear, iso means जो last carbon है तो उससे पहले यानी second last carbon पे 1 CH3. Neo means second last carbon पे 2 CH3. Vinyl, allyl, ethylidene chloride, ethylene chloride, dichloride, ethylidene chloride, एक ही कार्बन पे 2 क्लोरीन, that is geminal. ethylene dichloride, एक ही 2 कार्बन पे 2 अलग अलग क्लोरीन, that is vicinal dichloride. Then secondary, tertiary, and then acrylo and croton. C double bond C and C. The star mark C means it is a carbon of a functional group. Carboxylic acid, ester, whatever functional group is there. For ester we use et at the last. Like we used ic acid for carboxylic acid, we use et for ester. We'll deal with this in the IUPAC nomenclature, but right now I hope that is clear. We dealt with this, all these notes, you can refer to this. I will upload the notes after completion of the entire IUPAC nomenclature. Okay, so today we dealt with up to this much. Radical system and all these things we dealt, and in the upcoming lecture we start with this IUPAC nomenclature. So till this we completed. Revise it once from the notes that I'm showing you over here. Alright, and this part, the function group priority, I will deal with this in the upcoming lecture. Before starting the IUPAC nomenclature, I will give you the trick, I will explain you the trick how to remember the function group priority order. Very important. Without this you can't solve the good questions of IUPAC nomenclature. Okay, so that are the notes. Just practice all the questions. A good quality questions are there, ample amount of questions are there for practice, and I will upload this if I can, or else it will be uploaded after the completion of the chapter. Okay, so that's it for today.